happening tomorrow. Digital twin modeling to mitigate outages in fossil power plants. As can be seen in this photograph, that there is a man who is trying to use Oculus to model the physical behavior of a motor perhaps, or a turbine. In this world of digital twin modeling, which is now gaining huge popularity due to its incoming style and its impact on youth, I believe, uh, the digital twin modeling not just have its what we say, it's a new and a new service that is entering into the 2020 market, but it is also solving a huge possible problems which humans can't go. It is serving as a satellite unit. It is also helping troubleshoot problems by understanding the machines and their behavior. For this particular case study, we have chosen the digital twin modeling of power plants, which is predominantly fossil fuel power plants, and we are using this technique basically to mitigate outages. Let's see further. This is our digital twin team members, Kopika and Sweta. These were the targets that were intended to be achieved: diversification of ideas through perspectives of different minds, increased self-confidence to overcome potential barriers, ensuing professional growth, shared space and respect for each other's work, and willingness to work, publication of research paper in a competitive journal. So in a comprehensive 4-month remote program, we have basically understood a lot of uh, things that plague the industry of generation, the very tangible things that we connect through switch, a very basic latch that we are familiar with. But what is happening inside, let's understand this better. Scientific consensus indicate that Earth systems are facing unprecedented stress in the wake of rapid industrialization to meet accelerating human consumption, justified in the realm of economic development and industrial revolution. So we are having all this outstanding development. Maybe our price of electricity is also reaching competitive levels, but are we actually having a development in real sense? The temperature rise is projected to be at least above 3 degrees centigrade by the end of spending this century. Moreover, it states that even if we are in this generation where 73% of the plant emission of carbon dioxide is produced by electricity generation sector, what we as a generation can do to get this temperature of 3 degrees centigrade down the line, to have this net zero climate change, to have this no pollution that will basically eradicate our future generations directly. So it's a very important issue, and mitigating the adverse impact of climate change through reduction of outage can help restore weather patterns to normalcy, which gets deeply aggravated at local hotspots of fossil power plants. Let's further understand what is power outage. For a normal term, it is a tripping that a unit has not been now latched, that will now provide us any power. See this beautiful city, it is lit in colors of light. Even though there is a moon which is having its brightness through sunshine, in human world we have our brightness through electricity. What happens when this outage goes? what I mean, this outage happens. This outage, when it happens, the power that is transmitting through these transmission lines and making way to our homes is now affected, and our whole city is looking like this, a complete chaos and a lot of uh, a complete chaos and a lot of sudden outrage of price plagues the normal consumers. In this kind of situations, like our normal price, if it is like $2 a unit, it will go till to no extent we can behave the predict the behavior. It all depends on how worse the situation is. When it was in Texas power outage, the prices got really bad and people were paying immense price for using the basic electricity. So with this being said, uh, the outages are important, and we can't rely on moon and the sun to basically lighten the world. And we need to understand that these outages needs to be arrested. Impact of outages is not just limited to burning money, but it also has huge impacts on climate change. This one is a real photograph from a power plant. This power plant is right now emitting pollution, and it is uncontrolled. You cannot control this. Why you cannot control this? It is saying like yesterday I read news in which lawmakers are trying to impose a fine of $8 million to a company which is using wind turbines, and the cause is like eagles are dying because of the wind turbines, right? So what is the problem? Should they be fined, and all that money that is being raised should be passed on to the taxpayers? Is this okay? Okay, maybe it's okay because our eagles are definitely a huge sense of pride to us. But isn't electricity also a huge sense of pride which we often ignore before we make decisions to pursue it? Like in this case, why I'm emphasizing this is like wind turbines were always existing. The problem of birds were always there. But nobody saw this before. Why? Because it is the law that plagues the system. This power plant is not at fault when it is emitting pollution due to any reason, because there is some technical difficulties that are present when a plant is basically given a rise or a commission. Now how are we having this impact, and what are we talking about when we are saying burning money and climate change? The power plant with several outages tend to attract financial losses and hinder the efficiency of power plant, requiring frequent maintenance and overhauling budgets. More outages, more bad plant. Outages is not good for anybody, not for operator, not for a lawmaker, not for a consumer, not for any person on this earth. But still it happens. But it is possibly good for one thing in this world. What is that? It is good for machines, because when machines needs to blow up, they need to blow up. You cannot sacrifice dollars, $1,000 of machines and blow up the whole area if a tripping is happening, because it is important to trip the unit and at the same time suffer the consequences of it. But what we can do better is mitigate that. We have immense number of outages when a unit come into picture. So how can we mitigate it? We can mitigate because we have technology now. We have power plants which have higher emitting, and that is subsequently taken into consideration to retire. And what I mentioned about the previous slide showing this disgusting environmental collapse is why it is inevitable is like accumulating impacts of suspended particulate materials generate irreversible damage past irresponsible to the future generation. So why is it, how, who is to be attributable to it? It is the non-service of electrostatic precipitators before a threshold gas temperature is reached. Like if you have 110 degrees centigrade, then only you are allowed to get the ESPs or electrostatic precipitators in service, which will reduce that SPM level of to 50 or less than 50, which is the designated norm or allowable limit. So this is one of ways in which unit can be saved by getting the unit as early as possible, and avoiding the startups that take a huge amount of time to bring the unit back. The air pollution is very dangerous to our health. It has carbon monoxide, sulfur dioxide, nitrous oxide, which is emitted on daily basis to the environment. And just imagine 14,000 metric ton of coal is burning every day to produce 24 million units of electricity. So this 24 million units of electricity is having a strong repercussions on how much is the amount of pollution that is being emitted on a normal basis. And then comes the outage, in which it is going unregulated because we do not have ESPs, correct? So besides that, we have environmental, financial and health impacts, which can be which is no doubt a strange situation, because it is true, it is really true, you can see it. And this is water pollution, land degradation, noise pollution. This is case study project. You can see there is a national highway 2. This was my power plant. I would go from here and be here. This was my empire and a place to move everywhere I want. So I enjoyed being there, learning from there, and generating 1000 megawatt of electricity. It was being evacuated from 400 kV DSTPS RTPS double circuit line. There were 2 double circuit lines, and it is fascinating. They are huge, like you have heard about corona, right? But corona is also happening in transmission lines. When you pass beneath a very high tension line like 400 kV, you will be able to hear the humming noise. For that, for engineers, that is corona. So this is the power purchase agreement. As I was mentioning, like we have a lot of problems, as in case of example of wind turbines. The wind turbines were not going to just disappear and not kill eagle birds. Same, the power purchase the important thing is how you plan it. So when we planned this power station to come into picture, we just have 40% power purchase agreement, 10% with Tata Steel, like total 40%, and 60% of the electricity we didn't have any demand. So because of lack of demand, we would keep our plants shut down, a new plant shut down. So maybe this lack of generation from fossil fuel plants is done so that we do not emit pollution. But people need to understand this concept also, that if a plant is not running, when it will run, it will definitely give a lot of pollution, because that one is unregulated. So it is always good to have planned projects into picture, so that we do not have an outage because of no demand. So this was one of the biggest problems. The second problem we had was the two double circuit lines. They were having some problems, and though even though they were lightly loaded lines, they have issues getting the clearance from the right of way, and due to that, that 400 kV lines are having a light load. Due to light load, we always have this effect called Ferranti effect, and our power at the terminals is always greater than 400 kV. It will be like 430 kV, which is again a problem for machines because it causes stress and it can lead to outages as well. So with this slide, I want to emphasize, like, if a project is coming into picture, everything about it, like source of coal, power evacuation, purchase agreement, source of water, it has to be very, very, very well and meticulously done, so that we do not suffer the consequences of outages due to shortage of coal, lack of evacuation of power, or lack of customers that are interested to buy fossil power. Then case study: total power failure in Durgapur Steel Thermal Power Station on July 8, 2016. I was there when the tripping happened. The same project was done for International Convention of Quality Control Circle, where I represented as a team leader. The case study was selected and rewarded as excellent award. The cause of tripping here is tripping of unit in drum level due to non-availability of all these things, and the outage culminated into a whopping amount of 35 hours. So for 35 hours our operators were there working to restore the normalcy of the unit. What we think could be done better if we already knew through some oculus type of world that these are my parameters and these are the possible solutions that has resulted into this kind of tripping, and how can we mitigate it. So this is a case study which is going to be further explained in terms of monetary loss of oil and generation. As can be seen, it is a huge amount of monetary loss. It is 55 lakhs, which is 73,913 dollars, and here you can see it's 1.02 million dollars. Whoop, just like that. So in the next slide, I have tried to consolidate these impacts by getting a little bit deeper and getting the graphs. In the graph you will see that there is 12-point trend curve. There is actual load of 71 megawatt, which is represented by blue line. This blue line goes to zero when the outage has happened on 8 July, as I stated, and it comes back on this time. So for this time all these machines were running. Why these machines are running? These are needed so that we have we have to run the unit. Basically we have to get the steam rolling, we have to have some power to operate our auxiliary items. So these are high motors, 11 kV, then 3.3 kV. It's pretty dangerous kVs, but it's pretty beautiful motors, vertical, horizontal motors, all distributed across various levels of power plants. With this you can see like the rate at which the unscheduled interchange, you can say, if we could have capitalized on that, but at current situation we are having this total energy that is being consumed. Okay, this energy is being multiplied by this rate which we are importing from the grid right now. We do not have any electricity in our plant right now. So what we do, we import the power. When we import the power, we have to pay the price, and that price is pretty much higher than what we generate. So it is additional loss of $900 $898 here. And then in second unit we have how much? $3,600. Again, it can be seen with the trend, like how the unit is falling and coming back, and meantime how much is the current that is being drawn by the machines, and how much is the power that is being consumed, what rate it is being pursued, and what is the total amount. So next slide, it will be tangible and intangible impacts. Generation loss, declared capacity and scheduled generation unable to capitalize on unscheduled interchange during peak hours, which is direct, as we have seen $1 million getting loss because we have outage. Indirect monetary loss, heavy oil consumption in order to bring back unit to generation, auxiliary power consumption, loss of reliability and credibility. Who will like to buy power from me if I am just giving them a service that goes every 5 hours away? It's not a good thing to be in market then. So that are some of the points that I wanted to discuss along with this heat map. This heat map, you can see like the air, unhealthy air, dangerous levels, you can see highlighted in purple. Where this plant is located, let's figure this out. It is Kolkata, the capital city. This is Bardhaman, this is Dhanbad. So we are somewhere near here. Okay, as you can see, the Durgapur is not just a plant having 1000 megawatt of thermal unit. It is also having steel unit. It is an industrial city. So you see, when an city is on industrial side, how much is the impact, how much we are suffering from this. So this is the digital twin modeling now to understand how can we perhaps understand and solve those outages or mitigate those outages in a timely fashion, so that even if we have an outage, if we can get back the unit in 3 hours instead of 30 hours, it will have a huge profits. As well as when we have 3 hours wasted on fuel, the unit is already very much energized and warmed up to gain back its normalcy. So it will cause relatively less pollution, as for less time the coal that is being injected into the machines are going for a lesser time unregulated. With the potential of AI, we can transform the adverse impacts of climate by employing machine learning to match energy generation and demand in real time, effectively realizing the potential of smart grids, decrease unpredictability, increase efficiency, balancing power as well as use and storage of renewable energy. Neural networks to tackle variability issues with renewable power are developed to improve energy efficiency and reliability. The capabilities of machine learning can also help to improve maintenance, to reduce outage and energy resource forecasting, which increase control and maintenance efficiency. So this is this is one of the digital twin model, also known as fishbone or Ishikawa diagram. in which tripping of unit is being understood, and it's all the causes that lead to tripping of unit due to a fault is highlighted in four categorization: man, machine, method, and material. With this approach we can immediately trace back that a unit, if it has tripped due to drum level low, then how many causes are attributable at that instant to address that problem. So in this particular case study we have causes, sub causes, and a basic frame sheet in which we understand how these causes are valid at the time of tackling emergency. So this is that in the next slide we will see a unit that is tripping in drum level low. Both the recirculation valves get open and our instrument air pressure tank is having reduced pressure to supply and hold the valves. Guess if we knew that our compressors have just collapsed or they are not working, we would have different mechanism. We would have started immediately the MDBFP to basically root out the problem, or made a different supply available so that this tanker never reduce the air and hold the valves. But this was in effect only after the tripping happened. So these are the models that for a particular cause of tripping, if we know immediately how to backtrace this generator which is lying at 17 meter on a power plant, the drum which is lying at 85 meters, the BFPs which are lying at 8.5 meters, and these compressors which are lying at 0 meters are coordinated at 1 meter, which is as oculus meter you can say, or a digital twin meter, with which you can understand all of that happening in one place, that is control room, and get the solutions effectively. So in next slide I guess it's not working.
We have only these many slides.
Okay, so this is basically how a digital twin model is being presented to mitigate the outage and tackle these problems. And I have not yet that's pretty much it. Thank you.
How many minutes did it take? I think it was more than 15. Yeah.
I guess
You're all ready to present.